It says 34 to 68 minutes. First of all, that's a big time gap. Second of all, I don't know how long that's if it's gonna take me that amount of time if I end up talking to the chat or what. But I'm not getting off a stream until I get 100%. So, with that being said, I guess we'll go ahead and get started. Okay, so let's do it. Okay, here we go. Bro, if I could do this in one take, that'll be so perfect. All right. Anyway, oh, I gotta change some settings real quick for my tablet. Hold on. Dang it, I did not consider this. Cause my writing tablet only writes on the left side of my dual screen. Hold on 1 second, y'all. Dang, I'm mad I didn't think about this. All right, mapping. Monitor 1. Okay, I think we should be good now. Let me see. All right, yeah, we're in action. All right, so number 1 out of 34, bruh. Not trying to get any of these wrong. Hold on, it's still not working. Hold on. Mapping. I see what I did. Okay, bet. We should be good now, chat. Let's see. All right, yeah, there we go. All right, so number 1 out of 34. This is where it starts right here. So we're just evaluating a definite integral. Let's see how this goes. So it's the integral from pi over 2 to pi of negative x times cosine of x dx. Okay, so let's think real quick. U sub would not work. I think the only way to do this is by parts. It got to be by parts. Appreciate the like. So if I'm doing this by parts, I gotta define a u, and then I gotta define a dv, and then I can derive the u to get du, and then integrate the dv to get v. Once I figure out these 4, then I'm good. So I'm gonna go. Let's see. I'm gonna try to let u be, I guess, maybe just x. I'm gonna try to let u be x, and then let dv be negative cosine of x. I mean, I don't think the negative sign matters too much, but we're gonna try to start like this and then see if we can make some work. So just remember, by parts is when your integrand looks like this, and then we can write it like this. All right, so that's what I'm thinking. So I got my u and my dv. So if u is x, then du is just 1 dx. And then if dv is negative cosine of x dx, I forgot that part. Then v would be the integral of negative cosine, which would be negative sine of x. Because the derivative of negative sine is negative cosine. Okay. So now I'm just going to see if I can match up formats. Because I already got my original integral written as u dv. Now I'm just going to try to write this as uv. So that'll be negative x sine of x. That's my uv. Minus the integral of v, which is a negative sign. So since I'm subtracting a negative, I'm just going to go plus sine of x. And then du is just dx. So that actually looks pretty good. I'm not going to lie. Um, so let's see if I can get anybody in the chat. Let's see if I can double tap the screen 3 times. I'm trying to get 10 likes. If I can get 10 likes, that'll be clutch. But okay, so remember that this whole entire expression is from what? Pi over 2 to pi. We got to keep that in mind. All right, so the first part or the first term is good. The integral of sine is easy. That's just what? Negative cosine. Yeah. So this becomes this. It becomes negative x sine of x plus, actually no, minus cosine of x. Because the derivative of negative cosine is positive sine. Yes. All right. So I'm going to go boom, put this guy in brackets, and then I'm going to use my bar notation to remind me that I'm evaluating this thing from pi over 2 to pi, like so. And then let me just plug it in. Remember, to do this, I plug in the top bound into the entire expression, and then I subtract the same expression, but I plug in the bottom bound. So what I'm about to do is just replace x with pi. So that'll be negative pi times the sine of pi minus cosine of pi. That right there was my first when I plugged in the top. And now I'm about to minus and then plug in the bottom, which is a pi over 2. So that means I'll have negative pi over 2 times sine of pi over 2. And then minus cosine of pi over 2. Ooh, I'm getting close. Okay. Dang it, I'm mad I squeezed off a little bit. Actually, you know what? I'm going to be OCD just a little bit right now. Appreciate that follow, too. Wait, Yusuf, is this the Yusuf that I know? Let me know. All right, I'm going to go like that. Okay, so now we just got to evaluate. This will be negative pi. Sine of pi is 0. Okay, that makes that easy. And then we're going to go minus cosine of pi, which is negative 1. So minus negative 1 is just a plus 1. That was my first bracket. And then minus. And then the second bracket will be negative pi over 2 times sine of pi over 2, which is 1. And then minus cosine of pi over 2, which cosine of pi over 2 is 0. So it'll look like this. What grade is this? This is technically it's first year college or second year college, depending on where you go. But this class is often taught in high school as well. So my first bracket should just come out to a 1. And then I'm subtracting negative pi over 2. So I'm really adding pi over 2. I'm just doing it like this. This is just 1 plus pi over 2. The good news is that is an answer choice. That is good to see. So let's see. I'm getting 1 plus pi over 2, which is C. Let's go. Hey, 1 down, 33 to go. I'm not mad at it. Let's keep on grinding. Number 2. All right. Appreciate the likes. Oh, I asked for 10. I'm over here with 280 something. Let's go. All right. So they give us f of x, and it's a piecewise function. Everything changes at x equals 5, and then they're asking us to evaluate the integral of this function from 4 to 6. This should be light work. All right, so look, here's what's happening. Since this piecewise function changes at x equals 5, it's been a minute. That's what's up. Hey, see if you can remember this stuff from when you was in college. Appreciate that like too, by the way. So since things change at x equals 5, and 5 is in between my bounds, that means I'm going to have to split up my integral into two different regions. One region is going to be, instead of going from 4 to 6, I'm going to go from 4 to 5 and then plus 5 to 6. And then remember, the function that I integrate will depend on like what x value I'm at. So what this is going to look like, it's going to be the integral from 4 to 5. And then if you look at the piecewise function, if x is in between 4 and 5, then that means it's this bottom branch because x is less than or equal to 5. So that function that we're going to integrate there would be x minus 4 dx. And then to that, I'm going to add the rest of the region, which is from 5 to 6. And then again, in the piecewise function, if x is between 5 and 6, then obviously it's greater than 5. So the function that we're going to integrate there would just be 5 over x, but I'm going to write it like this just to make the integration a little bit easier for me. So that's what I'm looking like. All right, so first integral should be easy. That is just the integral of x, which is just x squared over 2, using reverse power rule, minus 4x, technically, again, using the same rule. And we're going to evaluate that from 4 to 5. And then I'm going to go plus. And then that 5, technically that could have went on the outside of the integral just because it's a coefficient. And then the integral of 1 over x is going to be ln of x. So I'm going to go like this. And then that would be evaluated from 5 to 6. And remember, if you are ever like skeptical about what you integrate, you can always derive what you integrated and compare it to the original. So like what I mean is 5 ln x, for example, if I was unsure, just take the derivative of that and you can see that that's 5 times 1 over x. So literally all I got to do from here is just plug in my top bounds and bottom bounds and then I'm done. So this should be easy. So I got what? I'm plugging in a 5 first, and then I'm going to go minus, and then plug in a 4. So when I plug in a 5, that'll be what? 5 squared, which is 25 over 2, minus 4 times 5, which is 20. And then I'm going to go minus, and then I'm going to plug in a 4 for x instead. So 4 squared will be 16 over 2, minus 4 times 4 would be 16. Okay, that was that first part. Appreciate the likes. And then to that, I'm going to put this in parentheses. I should have did different colors, but whatever. And then I'm going to go plus. And then this time, I'm going to go 5 ln of 6 minus 5 ln of 3. And yes, I do realize that both of those, I could have factored out a 5 to begin with. But I'm doing this from the perspective of like somebody's not learning this for the first time, but I guess I'm just trying to go like super duper step by step. All right, so from here, let me scroll. On that second term, I would factor out a 5, and then I would have ln of 6 minus ln of 3. I'll write this off to the side. I'm going to use the property that if I have ln of something minus ln of something else, that is just ln of the quotient of those two arguments. So I'm about to use that property on the second term. On the first term, however, that's just straight up arithmetic. Let's see, I got 25 over 2 minus, what's that, 40 over 2? So, dang it, man, I got to calculate stuff in my head now. 25 over 2 minus 40 over 2. 25 minus 40, what's that? Negative 15 over 2. And then this will just be 8 minus 16, which is negative 8. And since I'm subtracting a negative 8, that's really adding 8. But I'm going to write 8 like this for the sake of common denominators. So I got all of that. And then it's going to be plus, what do we say? 5 times the ln of 6 over 3, which is 2. So my final answer should be, what's negative 15 plus 16? That's just 1 over 2 plus 5 ln of 2. I didn't even look at my answer choices yet. Hopefully that's one of them. Let's see. 5 ln of 5 over 6. Okay, let's see. Oh, I know what I did. I made a mistake. Where I put a 3, I should have put a 5. I don't know what made me write that. So it's ln of 6 minus ln of 5. Okay, bet. What's up, Sky? So it should be 6 over 5. Okay, bet. See, that's the thing about having answer choices, man. I would have got that wrong just from literally writing one wrong number down. All right, Sky, W Roses, I appreciate you. Let's go. Thank you, Sky. Okay, so wait, I'm getting B? 1/2 plus 5 ln of 6 over 5. Okay, bet. Let's go. All right. Dang, I've been streaming for 17 minutes and I'm only on number 3. I gotta go. Sky, W donations, I appreciate you so much. Okay, this next problem, it is an indefinite integral of, let's see, ln of x squared all over x dx. All right, now this one, I'm not going to lie. This one is kind of cheap, the fact that there's answer choices, because if I really wanted to, I could just derive all the answer choices. But let's try to not do that. And man, you explain it so well. Your students are lucky. Man, I appreciate it, bro. Oh, what's good, bro? Do I sub? Oh, you sub. I thought you were saying, do I sub? Yeah, I was thinking you sub probably. But it has been a minute, bro. I'm back at it. So, yes, I agree to whoever said you sub. I'm thinking of letting u be ln of x. And then I can write that as u squared. And then the good thing I see is that this expression has an x on bottom. And so does du. So that's actually pretty clutch. Yes. Okay, bet. All right. If I'm not going to get 100, then we're going to get 100 on this thing together. I'm only on number 3, bro. And this test has 34 questions. I'm about to be streaming till midnight. All right. So if I were to write this in terms of u, let me switch colors. This would now be the integral of, I'm just going to go u squared. And then look, if I write a du right here, let's pay attention to what du actually includes. It includes a dx with an x on bottom. Look at what I have in my original expression, a dx with an x on bottom. So this is literally exactly what I want right here. And that is so much easier to integrate than my original. This just reverse power rules. So that's going to be u cubed over 3 plus c. And then, of course, I got to write my expression back in terms of x. Wait, why heartbreak? Did I mess up? Let me know before I come to an answer. So I got ln of x cubed over 3. I'm good. Okay, bet. Plus c. Okay, d. Yes, I'm getting d as well. Let's go. Bro, we're getting 100 on this. We are getting 100. Oh, number 4 is easy. Just from looking at that, I can tell that's light work. All right, so that is, let me write my problem out. That's the integral of negative 3x to the 4th minus 6x squared plus 8 dx. And then, unfortunately, they don't give us answer choices for this one, but it's all good. We're confident in our abilities. And this is just reverse power rule, so I'm not tripping. All right, so that'll be negative 3 times. And then if I were to go reverse power rule, I would add 1 to the exponent. So that'll be x to the 5th, and then divide by that new exponent. So boom. Are you the type of the person to put parentheses around the integrand? I am. I'm not gonna lie. I'm a parentheses over user in most instances. Just because it removes all like confusion, I feel like. Yeah, like ln, I usually do. I know I said I overuse parentheses, but if the problem doesn't have it, in some cases I'll just write it how they do it. But yeah, it does keep it more organized. I agree. But all right, so this would then be minus 6 times x cubed over 3 plus 8x plus c. And there are no bounds, so this should be my final answer. Let's see. So I got -3. Let's do it like this. -3 over 5 x to the 5th. Watch I get one wrong due to a typo. Minus, instead of 6 over 3, I should just be able to put 2 x to the 3rd power plus 8x. And then they already got the plus c. All right, chat, let me know before I hit enter. Am I good? Let me know. Because I'm not trying to get one wrong, bro. I'm good? Okay, bet. So if I get it wrong, it's not on me. It's on both of us. Okay. All right, we got a graph now. Let's see. Function f is graphed. Oh, gosh. They're probably going. I already know where they're going with this. They're going to have us calculate the area of something. I already know. Okay, yep. Find the integral of -1 from -1 to 5 of f of x. Give an exact answer as a multiple of pi. This is easy. As long as we know integrals represent areas under curves, we are good. Area of the right semicircle. Yes, from -1 all the way to 5 is literally just the area of a semicircle. This problem could not be any easier. Okay, what is this, number 5? All right, so I'm going to say the integral from -1 to 5 of f of x dx is going to be equal to, I'm just going to go pi, whatever my r is, squared, and then since it's a semicircle, I'm going to half that guy. 9 pi over 2, appreciate the follow. My radius will be what? From -1 to 2, which is 1, 2, 3. Okay, I have no clue what's going on. Wait, is this the Jaquez that I know? Or is this a different Jaquez? Let me know if this is the quiz that I know or not. But, okay, bet. I wouldn't expect you to just because you haven't taken this class yet. So it is completely normal for you to not know what's going on. But I'm getting 9 pi over 2. I saw somebody else in the chat said that. Yeah, 9 pi over 2. Okay, so 9 pi over 2. No need for a plus c. Okay, let's go. Yeah, okay, so this Khan Academy class is Calculus BC. Even though it's just covering integrals, they do include like partial fractions and integration by parts, which is BC. So if you're talking college, it's Calc 1, but if you're high school, then it's BC. All right, so yeah. I actually only did Calc AB as well. So after this test and after the next unit, I'm going to be like relearning the BC stuff. So that'll be a fun live stream. But all right, so the graph of G is shown below. Evaluate the definite integral. Oh, this is the same type of question we just did. So but I can tell they're trying to trick us because if you notice -9, there's like a little raise right here. I don't know if you can see that or not on your all screen, but we got to take that into consideration. So that's annoying. Why would they do it like that? Okay, so what I'm going to do, they cancel. It's an odd function. Yeah. Ooh, you're right. Yes. Because I was noticing like whatever area I get for the left half, the right half is going to cancel out. Because, yeah, I'm pretty sure they're symmetrical. Yeah, this one should be 0. All right, chat, 0. Let me know. Let me get a yes from somebody. 7 people in here. Somebody can agree with me that this is 0. Okay, bet. Okay, I'm just curious, out of genuine curiosity, what is their reasoning? Okay, don't overthink this. The net area is 0. Okay, yeah. Now, I'm not gonna lie. I will admit on camera that I was overthinking this because I was like, no, trying to figure out how to find that area, not paying attention to the fact that they were like half was on top and half was on bottom. But yeah, okay, bet. Let's keep going. All right, so we are on number 7 now. That last problem did not need any work shown. This one looks like it will be easy. FTC. All right, so they're giving us some function that is an integral, and then they're asking us to derive this integral. Now, some people, if you're overthinking this, you're gonna actually do the integral and then like derive that integral, but they cancel each other out. So G prime, here's what I'm gonna put. I'm gonna put, instead of G prime of 2, I'm gonna first put G prime of x, which should be equal to this right here. 3x squared plus 4x. All right, you already got the answer, bet. So yeah, that's my G of G prime, because integrals and derivatives cancel each other out. So all I gotta do from here is literally just replace x with 2. So that becomes 3 times 2 squared, which is 4, plus 4 times 2, which is 8. 12 plus 8 is 20. Let's go. Let's go. Oh, we're so locked. Let's go. All right, let's see. Approximate the area between the x-axis and h of x from 2 to 5 using a left Riemann sum with 3 equal subdivisions. The approximate area is blank units. And they even gave us a graph. How nice of them. Facts, we're super locked. Okay, bro, I'm calling it now. We're not missing a question out of all 34. Okay, so, and if y'all know people who like are in high school or like college, send them the live, bro. Let's get some shares and some likes. I'm trying to run it up. All right, so what do they want? Left Riemann sum, 3 equal subdivisions, so that's 3 rectangles. Me personally, I do this. I call it L1, L2, and L3. L standing for left, just to remind me. Oh, you already got it? Okay, bet. Hey, this bro is quick with it. Okay, so for our first rectangle, left Riemann sum means we're going to use the leftmost x value. So if we want to look at it graphically, the height of our first rectangle is literally h of 2. And we can either look at it, but I'm just gonna use the function that they give us. H of 2 is just 1 over 7 minus 2, which is 1 over 5. Think of that 1/5 as the height of my rectangle. And then if I'm going from 2 to 5 with 3 different like subdivisions, then each width is 1. Yes. Okay. Yeah, you got the answers. I'm just trying to kind of like, explain my work for the sake of the stream. But okay, so that right there is my first rectangle. My second rectangle, the height is going to be h of 3. And if I replace x with 3, that's going to be 1 over 7 minus 3, which is 1/4. And then all of my widths, oh, that's a hard word to say. All of my widths are all going to be 1. But okay, so that's my second rectangle. My last rectangle would be h of 4. Which if I replace x with 4, I get 7 minus 4, which is 1 over 3 times 1. So those are my 3 areas. All I gotta do is add them up. What common denominator do I want to use? 20, 60. I'm just spitting out answers to see if I'm doing it right. Oh yeah. No, so far, bro, you're carrying right now. Ooh, wait. Let's work smarter, not harder. They give us a whole calculator. Where'd they put it? Oh, here it is. All right. Actually, I don't even know if this is gonna turn it into a fraction for us. Let's just. Oh, actually. Yeah, let's just do it. Let's just pretend this was a non-calculator test, because this could very well be non-calculator. So I want my common denominator to be, let's see, 3, 6, 9, 12, 15, 18, 21. Could you utilize Desmos to solve calc problems? Yeah, for sure. In fact, on the AP test, On the calculator allowed section, they don't give you a calculator. They just give you Desmos. On the AP test, that is. But okay, so this will be, dang. Okay, I'm just gonna calculate this manually. I don't feel like doing extra work. All right, so this is a 1/5, 1 divided by 5, plus 1 divided by 4, plus 1 divided by 3. Whatever that comes out to be is what I'm gonna type in. Ooh. All right, you know what? I'm a cheat. Oh yeah, you can use your handheld as well. I'm a cheat. Well, it's not really cheating. I'm just using a different type of calculator. So this is, what was it, 1/3? My short-term memory is trash. 1/5 plus 1/3 plus 1/4. Okay, bet. 1/3 plus we got 1/4 plus we got 1/5. I can turn that into a fraction. That is 47/60. Bet. 47/60. Let me double check. 47/60, 1/3 plus 1/4 plus 1/5. 47/60. Okay, what's up? Let's go. All right, let's keep going. Number 9. The graph of a function g is shown below. Let f of x represent the integral from 0 to x of g of t. All right, so when I read this, just like test taking strategy right here, I'm just reminding myself that f of x is the area underneath this curve. So just so you know. All right, but anyways, they want us to evaluate f of 5. So let's just do this one right here. F of 5 means that I literally just replace x with 5. So that is going to be equal to the integral from 0 to 5 of g of t dt. That is literally it. And I can find that geometrically. Yes, me too. These ones are easy if you know what you're looking for. But all right, so it says from 0 to 5. That looks like a trapezoid-ish. I know some people are going to want to do that. Some people are going to want to just realize that there are 3 1x1 squares plus that little triangle right there. Yeah, trapezoid, that's the least amount of work, but it literally doesn't matter. You got a 1x3 rectangle plus you got a triangle in which the base is 2, the height is 1. And y'all know the area of a triangle is base times height divided by 2. Or I'm going to do it like this. I'm going to do it both ways. So this is 3 plus 1, which is 4. And you could have also did base 1 plus base 2. My first base is horizontal and it is 3. My base 2 is also horizontal and it would be 5. Divided by 2 and then multiplied by the height, which would be 1. So that would get you 3 plus 5 is 8. 8 divided by 2 is 4. So as you can see, no matter how you flip it, you get 4. Let's go. Okay, so far so good, chat. We're looking good. We haven't ran into too many hard problems yet. I'm expecting a partial fraction at some point here pretty soon. How about this? Every question I get right, you got to give me like 10 likes. I feel like that's not asking for too much. I try not to be thirsty for likes over here on this app. All right, so number 10, we're doing some U sub. It looks like we are integrating negative sine of negative x plus 2 dx. Okay, partial fractions are fun, man. I used to be so intimidated by them until I sat down and like learned it and realized that it's literally just algebra. It's literally not that bad. But okay, how should J define U? If it was me, I would let negative x plus 2 be U. That way I can write this as the integral of negative sine of U. So I say answer choice B. Somebody in the chat, let me know what you think. Oh, yeah, that is true. That is true. They don't. You're right. But do y'all agree? Negative x plus 2? Let me know, somebody. Oh, Jaquez, I didn't even see the gifts. Bro, I need to make it to where it plays a noise whenever I get a donation. I appreciate you. You and Sky came through clutch. All right, you say B? Let's go. Okay, number 11. This is straight off of flashcards. If anybody took my class, all these types of integrals, you got to know like rapid fire. So here's what I'm gonna try. I'm gonna first establish this right here and make sure that we know how to do this. Because if I know this, then this answer is easy. Integral of secant tangent is secant of x. But before I take that and roll with it, I'm not going to lie. I got to confirm. Oh, never mind. You already confirmed for me. Secant of u. Yes. Okay, bet. Me and you were thinking the same thing. Now, just so y'all know, a couple years ago, I made a document of all the calculus things you need to memorize. So all the like derivatives, all the theorems. I should share this or like make this publicly available at some point. But my calc students literally have to have this whole document committed to memory. It looks so intimidating too. I show them the whole thing on the first day and they get scared, but it's actually really clutch. But I'm going to use this to double check my integral, the integral of secant tangent. Is that even on here? It should be. Is it not? Oh, wow. It's not. But the good thing about derivatives and integrals is if I don't know that, I can check the derivative of secant, and you can see that it is secant tangent. So, yeah, we're good. We're good. Dr. Super Delicious confirms bet. Okay, so if I know this, then like somebody else said, I can do U sub. Yeah. This one is one of those like sleeper problems that you either know it or you don't. So I'm gonna let U be 2x. And since I'm doing this problem, I might as well say, my students personally oftentimes get this one wrong. Well, let me not say they often get it wrong, but the bounds. There was one test question I remember. It was U sub with bounds, and they forgot to put the bounds in terms of U. And I think only one person out of everybody got it right. A PhD in applied math. Oh, I'm following you. That's crazy. A PhD is crazy. Let's go. I just got a little bachelor's. But okay, so if U is 2x, then du must be 2dx. Okay, so now I'm going to... Oh, you don't need to do U sub, just divide by 2? I didn't even think of that. I did not think of that. Yeah, that is true. Dang. Good call. Yeah, I like that. So, yeah, that works. Because once you integrate this, it'll be the integral of secant u times tangent u, which is literally just equal to the secant of u. And in that case, that'll be the secant of 2x. And when I plug in my bounds, in this particular case, I don't have to worry about changing my bounds because I'm leaving everything in terms of x. However, if I left things in terms of u, I would have to put those x values in terms of u. Secant of 2x divided by 2. Yeah. That is smart. I like that. That is cool. Okay, so to evaluate this, I'm just going to replace x with a pi over 6. So, and then me personally, I don't like evaluating secant, so I'm just going to rewrite this as 1 over cosine. And 2 times pi over 6 is the same thing as pi over 3. So that's my first iteration, and then I'm going to go minus, and then the same thing, but I'm going to replace x with 0 this time. So that'll be 1 over the cosine of 0. 2 times 0 is, of course, 0. Yes, I appreciate the rose. Dr. Super Delicious, I appreciate you. Yes, let's go. Okay. Oh, yes. Divide by 2. Yes. I read it, but I didn't register it in my brain. Yes. My DU doesn't have a 2 in it, so I do have to multiply this entire thing by 1/2. Yes. Thank you so much for reminding me. I'm glad I read the chat. Yes. Okay, so this whole entire thing, I'm going to slap a 1/2 in front. Like so. Okay, thank you so much. Let's go. All right, so from here, I'm going to evaluate cosine of pi over 3, which I'm going to draw my brain on paper real quick just so y'all know how I do it. I am not the best at memorizing trig. Yeah, real analysis, bro. Real analysis fried me, bro. Surprisingly, it was a lot harder than complex analysis, which, how does that make sense, right? But, okay, so to evaluate this, I know that pi over 3 is what, 30 degrees? I mean, I'm sorry, 60 degrees. So I'm going to go something like this. And when I look at this point, I just know that right now, the x coordinate is smaller than the y coordinate. Because remember, the center of this circle is at 0, 0. Ooh, that was sloppy. Hold on. 0, 0. Yes, real analysis is very difficult. But if I know that this is 60 degrees and I can see that the x coordinate is smaller than the y coordinate, and so the only possible coordinates are 1 over 2, root 2 over 2, and root 3 over 2. And so if I'm cosine, then I know that that's the x value, which we just said was 1 over 2. That's the smallest x value. That's what I always do. If I don't feel like, or if I don't just like memorize it off the top of my head. So yeah, there's that. And then let me keep my brackets. So that's 1 over cosine of pi over 3 minus 1 over cosine of 0 is 1. So this really just turns into a 1/2. And then I have 1 divided by 1/2 is the same thing as 2. If you keep change flip. And then 2 minus 1 over 1 is 1. So I'm getting 1/2 for my final answer. 1/2 times 1 is 1. Okay. 1/2. Hopefully I'm right. Thank you to everyone that reminded me to divide by 1/2. But let's see. Let's go. All right. We are moving right along. Okay, number 12. Approximately a third of the way through. 140 bit. Yeah, this one's easy. If you just think about the graph of y equals 10, you know it's just a straight line. I'll draw it. I don't know why I'm using my hands. I have a whole tablet right here. So, whenever you're integrating a constant, just know that a constant function is literally just a straight, not a straight, but a horizontal line. Let's just assume that that's y equals 10. And if I'm evaluating this from -6, I should have drew my y-axis more in the middle. But conceptually, this should still make sense. Let's say that that's -6, and let's say that that's 8. You literally just have a rectangle that you're calculating the area of. So from -6 to 8, that is a span of what, 14? If you go 8 minus -6, and then you take that 14 and multiply it by the height, which is 10, and that should give you 140. Alternatively, look, just for the sake of education, if you didn't recognize that, you could have integrated it and got 10x, and then just did this as normal. So you would have got 10 times 8 minus 10 times 6, or 80 plus 60. Okay, let's keep moving. Continuum mechanics. Good Lord. Just when you thought math couldn't get any harder. Okay, LF4, appreciate that follow. Okay, let's see here. So we got capital G of X, lowercase g of X is the equals the derivative of capital G of X. So they want to know the integral from 3 to 12 of G of X. Okay, so remember, here's what I would write for this one. FTC, we know that integrals and derivatives cancel each other out. So we know this. And since G prime, or since capital G prime is the same thing as lowercase g, we can say this. Actually, I'm going to do it like this, as a matter of fact. I'm going to say I can write the integral of G of X, which is what they want us to find. Since lowercase g of X is the same thing as capital G prime of X, obviously I can interchange them. And then the integral of a derivative is just the function itself. So there's that. So when I integrate G of X, that's just literally going to come to this. Capital G of 12 minus capital G of 3. And whatever that is, that should be our final answer. The integral of lowercase g is capital G. All right, so G of 12 is the square root of 3 times 12, which is 36, minus the square root of 3 times 3, which is 9. Square root of 36 is 6, minus the square root of 9 is 3. Final answer should be 3. Okay, 3, you got it, bet. I love when I get an answer and somebody in the chat has the same answer. Let's go. Ryan, what's good? Okay. We are on number 14. We got 34 problems total. But we have not missed one yet, thanks to the chat. If it wasn't for y'all chat, I probably would have got like at least 2 or 3 wrong. Not even kidding. Okay, so number 14, a freight train leaves the station on a 4.5-hour trip. The graph below shows the velocity as a function of time. Okay, that's pretty important because we got to remember, derivative of position is velocity, therefore integral of velocity equals position. That is a very important concept that I feel like is worth writing down, so I'm going to do that. This is just more so a concept that we have to consider. Most people call position x of t. I've seen s of t. It really doesn't matter. But so we got a velocity time graph. The question says, how far does the train travel? Which is just the displacement, which is just the integral of velocity. So what we are trying to technically find is the integral of this velocity function from, it looks like from 0 to 4.5. I think they told us that it was a 4.5 hour train ride. But that is just finding the area. So me personally, what I think I'm going to do is, let's see if I can draw on this. Does it let me? Oh, it does. If y'all can see that, I'm just going to choose to take a rectangle and then the 2 triangles on either side of that rectangle. So that rectangle, the width looks like it goes from 0.5 to what? What is that? 3.5. So a distance of 3. Okay. So that would be my height. And then, or my width rather, sorry. And then my height is clearly just going to be 40. And then to that, displacement's accumulation. Yes. My students love, or they get tired of me saying that word accumulation. During this unit, we said that word at least 840 times. Okay, so I got the rectangle, and then for the triangle on the left, the base looks like it's 0.5, and then the height looks like it's 40, and then divided by 2 because that's the area of a triangle. And then the other triangle also has a height of 40. This one, however, looks like it has a base of 1. So this would be plus base, height is still 40, divided by 2. Okay, so, all right, now we just add stuff up. Is this multiple choice? Oh, we got to type it in. Okay. So, 3 times 40 is just 3 times 4 with a 0. And then plus 0.5 times 40 is 20. 20 divided by 2 is 10. Plus 40 divided by 2 is 20. So my final answer that I'm getting should be 150. 120 plus 10 is 130. 130 plus 20 is 150. Okay. Let's see if I'm correct. Real quick, 40. That width was 1, 2, 3. Let's go. Okay. Improper integrals. I don't have the most experience doing these, but I feel like we can get it. Okay, so they want us to evaluate the integral from 2 to infinity of 1 over the square root of x dx. It diverges. Super delicious. Tell me if this is correct or not, because I'm in the process of learning BC. Do we know that it, or could we tell that it diverges from a P-series test? P-series, bet you beat me to it. Dang it. Okay, never mind then. So yes, due to P-series tests, we can just say it diverges. Now the thing about that is, in this particular unit, I guess they assume that you haven't covered series yet. So I say it's D. Obviously we think it's D, but out of personal curiosity, I want to see if I can solve this one instead of just using a test. Honestly, just because I want to practice this skill of evaluating improper integrals, because I remember we can write it as the limit as some variable approaches infinity. We'll call it n. And then we can write it as the integral from 2 to n of that expression. And since we're integrating, I'm going to write this in a more integratable way. That'll be x to the negative 1/2 dx. Okay, the PhD in math says work it, so I'm gonna do that. So reverse power rule means I would add 1 to the exponent. So negative 1/2 plus 1 will be 1/2. And then I divide by that new exponent. So dividing by 1/2 is the same thing as multiplying by 2. So I should get this, which is the same thing as 2 root x. And I'm evaluating this from 2 to n. All right, so what this would look like is I'm going to plug in n, and then I'll go minus, and then I'll plug in a 2. But since they both have a 2 in common, I can just factor that out. So this will be 2 times. Actually, no, it won't be 2 times. I forgot my limit notation. Yes. We are on the same page. I'm too loose with my work. This is not just an expression. This is a limit as n approaches infinity. Yes. Doing math on live will get you will get you good. I guess it's really, I guess I should really write it like this. I'll just write it like this, because this is really what we're trying to find. Okay, so this becomes limit as n approaches infinity of 2 times the square root of n minus the square root of 2. Am I on an iPad? No, I'm using Microsoft OneNote. right now on my PC. But what I'm writing on is, hang on, I can show you. It's a writing tablet. It's so clutch. It's wireless too. But yeah, it's really just like a mouse, basically. Stylus / mouse. It's really clutch. I tried to do it on my iPad before, but it's just less connections to do it this way. So here, if I were to evaluate the square root of n as n approaches infinity, that just approaches infinity. So we can see that it diverges. Dang, there's 2 PhDs of math in my live. Let's go. I'm following you too. That is so cool. Maybe one day I can get mine as well and I can join y'all. Okay, so diverges. Let's go. How did they do it? Did they do it? Yeah, they did it the limit way, because we don't know series yet. Okay. Definition of integral using Riemann sums / summation. Let's see if we can get this one. Okay. These ones were honestly a Doug. A donut. I appreciate it. I'm not sure what a donut is as a gift. I've never gotten one before, but I appreciate it. Let's go. And I appreciate the follow. Okay. Next question. We are trying to use summations to evaluate the integral from 0 to 3 of e to the x dx. Now, this one I feel like they kind of blessed us, because if our interval starts at 0, like that's our first height of our rectangle. So we don't have to really add anything. I haven't done calc in years, but I've been following your page for a while. Let's go. Love your energy and keep up the great work. I'm trying, man. I'm trying to be more consistent. Luckily, I'm a teacher on summer break and I don't have anything to do. So there's no reason why I shouldn't be more consistent. Okay, so, Dylan, appreciate the follow. Now, we know that we are going to add up a whole bunch of rectangles. The width of each rectangle is delta x, which in this case will be 3 divided by n, I believe. Let me look at all my answer choices. Okay, yeah. Just from the answer choices alone, I'm thinking either B or D. Okay, sweet. The PhD confirms. Now, I know I want to take a limit as n approaches infinity, because as n approaches infinity, my rectangles get skinnier and skinnier, making my area approximation more accurate. And I'm going to start at 1 and go all the way up to n. Now, my first y value, it'll be f of 0 plus delta x. I'm going to write that down. F of 0 plus delta x, which we said was 3 over n. That is the height, and then the width is 3 divided up into n rectangles. You got D? Okay, sweet. Okay, so yeah, now all I got to do is take f of 3 over n, and our function, I guess I should write this down too. I'm going to record this stream, by the way, so I'm kind of using it as a bit of a tutorial, which is part of the reason why I'm like kind of showing every step. But if f of x is e to the power of x, then f of 3 over n would be e to the power of 3 over n. And I'm going to multiply that by my width, which is 3 over n. So boom. I forgot the I. Oh, yes. Oh yeah, it's times I. 3 over n times I. Yes, I forgot the I. I'll just do it like this. Yes. E to the power of 3i over n. Yes, I did forget the I. There's so many little things to remember. Okay. Let's go. All right, next question. They give us a table of values of a continuous and increasing function. Okay. Actually, let me show this part because that matters. The fact that it's continuous and increasing. We're interested in the area under the curve between x equals 4 and 9. We're considering using left and right Riemann sums. We are ordering them from least to greatest. Okay, left, actual, right. Yes. The fact that the dead giveaway on this problem is the fact that my function is increasing. So just for a quick sketch, if I draw any continuous increasing function, such as this right here, you can see the difference between left, right, and actual area. So if I just take a few segments of a left Riemann sum, you can see that that left Riemann sum is less than the actual area because there's like little moments of, what do you want to call it, underestimation right here. And then the right Riemann sum would be the exact opposite of that. So if we're going from least to greatest, then the least area would be the left Riemann sum. Actual area is right in the middle, and then a right Riemann sum would be like an over approximation. Yes. Okay. Bro, Vortex is a calculus lord. Let's go. Okay. Let's see. Do we want to go partial fractions on this one? That's what I'm thinking. U sub would not work. By parts does not look like it'll work. Now, yes, partial fractions. Okay, so legit question to the chat. I go through all of my like integration techniques and kind of rule out possibilities. Is there anything that I should look at in particular that tells me partial fractions? Divide first, polynomial division. Ooh, okay, yeah. Because I see an expression over an expression, and my first thought is partial fractions. But yeah, we can try to do polynomial division on this. Question is, do I remember how to divide polynomials? Let's see. The powers match. Ooh, okay. Ah, okay, I see. All right, so let's see. I haven't done polynomial division since like, we did this in algebra 2 in like, I don't know how many months ago. But the powers matching, I can definitely see that being something to like take note of. We jump straight into conclusions. Yeah, I feel like integration and integration techniques is just a matter of just like observation skills. Can also do synthetic. Yes, you can do. Bro, I haven't done this in so long. Synthetic division. Let's do it. What I remember is you draw like something like this, and then you put the 0 of the denominator right here, and then all of the coefficients right here. I think I'm doing this right. And then you drop your first number down, multiply these two, and then add down. I think that's how it works. Okay, yes. Sweet. So this quotient should be what? 3x minus 5? Oh wait, no. It's just 3. Yeah, is it 3x minus 5 or 3 with the remainder of 5? Because an x to the 1 divided by an x to the 1 should just be negative 5 over x plus 3. Okay, yeah, the negative 5 is my remainder. But wait, is it so since negative 5 is my remainder, is it 3 plus negative 5 over x plus 3? Or how does that work? I haven't done synthetic in so long. 3 is the constant. 3 minus, okay, yeah. 3 plus negative 5, same thing. Yeah, okay, good. So that is essentially what we're trying to integrate. So my problem then becomes, let's write this out. So I'm trying to integrate 3x plus 4 over x plus 3 dx. Anthony, what's good, bro? Which is the same thing as the integral of 3 minus 5 over x plus 3. Okay, bet. That makes sense. Okay, so then that means, let me move this synthetic division out of the way real quick. So that then means that this could be equal to 3x. And then, so it's either B or C, or B or C. And then I can write this as minus 5. Actually, I'm going to do this for the sake of showing my work. I can write this as minus 5 times the integral of 1 over x plus 3. That's what I would prefer to do, because that way I can see that this integral is just ln of x plus 3. So my final answer will be 3x minus 5 ln absolute value of x plus 3. People in the chat, I do have a legit question because I don't know the answer to this. Why, or does anybody know why integral of 1 over x is ln of absolute value of x? Students have asked me that before, and I don't know why the absolute value is necessary. Does anybody know? I always just say it's because natural logs inputs have to be positive. Okay, so I am right. That's what I always tell people. I always tell people, if you look at the graph of ln, none of the inputs can be negative. Yeah, okay, sweet. So I told him the right thing. All right, so I am getting B. Yeah, B, yes. Hopefully everybody is in agreement with B. Wait, no? Uh-oh. Hold up. Is it no to B or no to, oh no. Okay, wait. I gotta see what I did wrong. Wait, I don't know if answer choice B is correct or my reasoning is correct. Let me know. I'm gonna wait, because I don't want to get this wrong. No to absolute value. Okay. Okay, good. I was like, I don't know where I messed up on that one. Okay, but if you don't mind, could you explain why the integral has absolute value? Because I legitimately do not know. All right. Integration by parts. Number 19. Let's see. Yes. I feel like this is a pretty obvious by parts. U sub will definitely not work. Tabular. Can you join? Yes. I haven't. Let me see. Yes. I think this is how you do this. I've never invited somebody before. Let's see. All right, I just sent you an invite. Okay, sweet. Hello. This is so cool. Okay. Mm-hmm. 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 Mm. Mm. Got you. Mm-hmm. Ah, I see. I see. That, yeah, that makes sense. That makes sense. Mm-hmm. Mm. Okay. I've never had anyone explain that to me before. That makes so much sense. Mm. Mm. Just to like, got you. Okay, that makes so much sense. Sweet. Nice. Okay, thank you so much. Yeah, that sounds like way too much to type. Okay, sweet. Well, I appreciate you. Mm-hmm. Mm. Right. Ooh. Okay. Okay. I that makes so much sense. I never thought about that before. I like that. That's a good explanation too. Nice. Well, thank you so much for your explanation. I'll. I think I can disconnect on my end. All right. Thank you. Okay. Okay. Sweet. Yo, that is cool. Okay. So Nibba Juice, the problem or the question that we were talking about was just why the need for absolute value bars whenever we um, integrate. I mean, yeah, integrate ln of x or one over x. She was just talking about why we need absolute values. That is that is something that I literally never thought about before. But okay, let's keep going. I think we are on number 19, I believe. Yeah, we were on by parts. So if we're going by parts, I want a U and I want a DV. Oh, tabular. Yes. So tabular, are you referring to just like literally by hand making a like explain what you mean by tabular cuz I've never done it that way before. If you can type it out. I don't know if it's like a lot to type out. The DI method plus minus. Huh. I'm not familiar with that method. I'm not even going to lie to you. I'm going to I'm going to Google it real quick just to see like um I don't even know what to type in. The tabular method, SDI. I legitimately don't think that I've ever learned this method before. I won't do it all right now, but um that looks super convenient. Is that just a and take the derivative? Okay, you can only do it once. So is this tabular method like a substitution for by parts or what? If there's a power on the x, then you use it, but you could. Yeah, I need to familiarize. I'm gonna leave that tab open, so I can learn that method. Okay. Well, I guess for now we'll do it by parts. It's an easy method if you recognize the form. Okay, that gives me something to do for tomorrow. I guess it would take max makes it fast. Okay, yeah, I'm gonna learn that for sure because I need to know that. Um, okay, so for integration by parts, I was always told that in terms of picking your U and your DV, pick the U should be the one that's easier to derive. Let me know if that's like if there's any truth to that or not. Um, cause like, well, actually, cause if I'm doing UV minus the integral of V du, that du, let's just try it. Let's just try it. So if we let u be e to the 5x, then its derivative would be 5e to the 5x. And then in that case, that means dv would have to be x, making v x squared over 2. Hmm. I don't have a good feeling about this. I have a feeling we might want to switch our u and dv, but I could be wrong. Let's just try it. So if I go u times v, that'll be e. Yeah, I would. Okay, yeah. Lyate. Okay, okay, yeah. I heard about lyate before. What is it? Logarithms, inverses, algebraic functions, trig functions, and exponential functions. Whichever one of those comes first is what you want to choose for you. Okay. So if we use that, There's no logs. There's no. So I guess the x would count as algebraic. Yeah. Okay. Yeah. I love when I say something and I see it in the chat at the same time. That gives me so much confidence. All right. So in that case, we'll switch them. We'll let u be x, and then we'll let dv be e to the 5x dx. Okay, so if u is x, that means that du is just going to be 1 dx. And then if dv is that, then the integral of that, the integral of e to the 5x, it would be 1/5 e to the 5x. In my head, I was like, that sounds like I need u sub, which I guess I technically kind of did u sub. Okay, so now that we have our u and our dv and everything, let's try to piece this together. So uv would be, how can I write this? 1/5 x e to the 5x. Okay, sweet. You got C? All right, cool. So that is my uv minus the integral of v. And for my v, that 1/5, I'm going to put on the outside of the integral. And then v is e to the 5x. dv is also e to the 5x plus a dx. So I'm going to write that as, let's see, x over 5 e to the 5x minus 1/5. Now, what I would be doing is integrating e to the 5x squared, which is e to the 10x. Let me write that off to the side. E to the 5x squared would be the same thing as e to the 10x. Let me know how that's looking. All right, so then I'll be integrating that, e to the 10x dx, which would require u sub. U would be my 10x, which means that du would be 10, which means I need to multiply by a 1/10. Hold up. These aren't looking like my answer choices. Let me backtrack. My first term looks right, but somewhere in my second term I messed up. Hold on. dv, the integral of e to the 5x should just be e to the 5x in the integral. Okay. So I see where I messed up. I thought of it as v dv, where it should have been v du. That's my mistake. Okay, I was like, something doesn't look right. All right, so v times du is this times dx. Okay, bet. Crisis averted. We're good. Okay. Oof. Chat, y'all are keeping me alive right now, man. All right, so I got x over 5 e to the 5x minus 1/5 times. We know that the integral of e to the 5x is 1/5 e to the 5x. So if I multiply that 1/5 by another 1/5, I see that that would give me 1/25 times e to the 5x. Then I guess I can erase this and put a plus c. Oh yeah, I see what you mean. Yeah. Okay. One thing that I've noticed is that talking and writing is not my best strong suit. Whenever I'm talking and looking at the chat and doing math, I always make some mistake. Okay, so we're saying C. Let's go. All right, we're making progress. Number 20. It's hard to multitask. I know. I got to lock in for real. All right, so they're giving us capital F of x, which is some integral, and then they want us to derive that integral. So we're taking a derivative. However, we know that derivatives and integrals cancel out, but we got to look at our bounds. So if I were to know that integrals and derivatives cancel out, it wouldn't just be a 3t. I would plug in my top bound. like so. And since I'm taking a derivative and that inner inner cosine of x is a function, I need to use chain rule, which means I need to multiply by the derivative of cosine of x. Okay, and then I'm gonna go this is my answer, but just to show everything fully, I'm gonna subtract and then I'm gonna plug in a -2, but I'm still gonna use chain rule because -2 is technically a function in which its derivative is 0. So that right there is my final answer. Fundamental theorem of calculus. I'm going to say -3 sine of x cosine of x as my final answer. That should be correct. 3 cosine. All right, let's see. -3 sine of x cosine of x. These only worry me because I hope I type it in right. But I should be good. Thumbs up. Let's go. Okay. Well, we are moving right along. This is a lot of questions. 34 is a lot. Okay. Integral. This one should be super easy though. Reverse power rule. X to the power of 3/4 dx. I can use this rule by adding 1 to the exponent. So 3/4 plus 4/4 would be 7/4. I would divide by 7/4, which is the same thing as multiplying by 4/7. Don't forget my plus c. And that should be it for that one. So let's go 4/7 times x to the power of 7. Oops, do I need parentheses? 7/4. Okay. Just to double check, 3/4 plus 1. 3 plus 4 is indeed 7. Flip the fraction. We should be good. Let's go. Oof, I really hope I don't miss one because I need 100 and I'm not trying to start over from the beginning. Okay, this is the graph of f. Let g of x represent the integral from 0 to x of f of t dt. It looks like there's an x-intercept at some c value. What is an appropriate calculus-based justification for the fact that g has a relative maximum at x equals c? All right, so let's just read the answer choices first. F is decreasing. F crosses the x-axis from above it to below it. F has an inflection point at c. Off at first glance, I want to say B. Let me zoom out just a little bit so we can see everything at once. Let me zoom out a little more. Hopefully y'all can read the words when I zoom out this far. Okay, so G has a relative maximum. So if I were to show my work, yeah, you think B? Okay, me too. All right, so for number 22, G prime equals F. Yeah, so if G is an integral, and if I derive both sides, G prime, well, let me write this down first. We know that G prime of x equals f of x due to the fundamental theorem of calculus. And we know that at maximums, relative maximums, G prime needs to be equal to 0. Not only does it need to equal 0, it needs to go from an increasing to a decreasing function. So that means G prime or F needs to go from positive to negative, which at C, you can tell it does that. So not only does it cross the x-axis, it goes from above to below, which is how we know it's a relative maximum. You're taking AB next year? Bet, this is the stream for you. This is what you're going to be seeing. Okay, B, yeah, inflection point doesn't specify a maximum, and a decreasing function has no mention of the fact that it touches 0. Okay, I always try to justify my reasoning here. FTC, yeah, basically what we said. All right, let me zoom back in. Okay, we got a midpoint Riemann sum. This one should be light work. It's completely unrelated to your intended major. Hey, if I say if you don't need it, don't take it. No reason to put unnecessary like stress on your brain. But all of like probably like 90 something percent of the problems on this test that I'm doing right now, you're gonna see an AB. So just keep that in mind. All right, so approximate the area between the x-axis and g of x from 1 to 4 using a Riemann sum with 3 equal subdivisions. Okay, so I'm going to calculate M1, M2, and M3. M, of course, standing for midpoint. And the good thing about this one is all of the subdivisions are equal, which means all the widths of my rectangles are going to be the same. And if I'm going from 1 to 4 with 3 subdivisions, then each width is going to be 1. So that's a good thing about it. So really all I got to do is find the height of these rectangles. Is this AB or BC? So this test right here is BC. This is a BC test. Okay, so for the midpoint, we need to calculate the height at the middle between 1 and 2, which is 1.5. So we need to, it'll be like this. Since my function is just taking the input and squaring it, it'll be like that. Did they give us a calculator? Okay, bet. All right, so that, and then the other x value will be 2.5 squared, and then 3.5 squared. And then we're just going to add all of these up. I'm just going to be lazy and use a calculator. So we got 1.5. I wish there was a way to square stuff on here. I don't know if there is or not. But anyways, so we're just going to square each one of these. So this will be 2.25 plus 2.5 squared. Do I want to just do this as a... Nah, I'll just do it like this. Plus, we have 2.5 times 2.5. Plus, and then we have a 3.5 times 3.5. Okay, that is 1.5 squared plus 2.5 squared plus 3.5 squared for a final answer of 20.75. Let me write that down. Sum equals 20.75. Okay, let's see if we are correct. 20.2. Ooh, almost made a typo. 20.75. Now I'm starting to second guess myself. Okay, 20.75. What if we were to express it as a Riemann sum equation? What would that look like? As an equation, I mean, it's just areas of rectangles being added up, honestly. So this M1, M2, and M3, it's really just like a base times a height. And so it's more of like an expression rather than an equation, Chris. But okay, are we correct? Let's go. All right, number 24. Let's keep pushing. All right, integral of 16. I'm just going to throw the 16 out front. Integral of cosine of x dx. Integral of cosine is just sine because the derivative of sine is cosine. So that right there should be my final answer. I'm going to dip. Okay, thank you so much for sticking around. It was so nice to meet you too. Thank you for your help. I appreciate you for all of pointing out all of my mistakes. I'll catch you next stream. Is integration by parts? Yes. I think we did like 1 or 2 integration by parts problems already. But yeah, Dr. Super Delicious, she is goated. Definitely make sure to give her a follow for sure. Everybody, go follow her. PhD in math is crazy. And she sent another donation. Let's go. She is the GOAT. Okay, so It gave bounds of 1 to 4. Yes. I wish I could go back, or can I? Oh no, I can't. Okay. Anyways, um, yeah. Okay, we're good. All right. So, this one should be 16 times sine of x. 16 sine of x. Okay, and then just to check, if I were to derive this, that would be 16 cosine of x. So I should be good. Let's go. Bro, we're getting close, bro. If you can look at the bottom of my screen, I don't know if I can scroll right now, but we're getting there. 34 questions total. I'm pretty sure this is number 25. All right. So I know in the chat y'all were talking about like Riemann sum approximations. Here's another Riemann sum question. Loving your streams, by the way. Taking BC this summer. Oh, bet. Let's go. Make sure to give your boy a follow in that case. Okay. So Chris, just so you know, I've taught AB for now 3 years. I've never taught BC, never took BC in high school. So the last time I like actually worked with BC content was when I was in college, which I'm going to tell my age here, but I don't care. I took like calculus 2 in 2011. You never took BC? Yeah, me neither. I took calc 2 in 2011. It was 14 whole years ago. So understandably, I forgot some stuff. So when we get to unit 9, I'm going to be relearning for sure. Okay, so Riemann sum. Let's just see what it says. Which of the following approximates the area between the graph and the x-axis from 1 to 11 using a midpoint Riemann sum with 5 equal subdivisions? Ooh, okay. So let me zoom out real quick so we can see everything at the same time. All right, so if the font is too tiny, y'all might need to go full screen and like rotate your phone. But yeah, self-studying is fun because you can just move at your own pace. You can pretty much figure out anything you need to with like AI. But okay, so midpoint Riemann sum. We see that the width of each rectangle is 2. So that, actually that does help. We know it's either A or B. That's actually clutch because you can visually see that each width is 2. So now it's just a matter of, is the function 2 times I minus 3 or 2 times I plus 2? Well, the function is the absolute value of x plus 5. So let's see. If we're using absolute value of x plus 5 as a function, let's just see what our heights are. I'm just going to call them h1 and h2 and h3 so we can see if there's like a pattern that we notice. Yeah, Khan Academy is super helpful. Okay, so if I were to use this function to find my first height using a midpoint Riemann sum, it would be 2 minus absolute value of 2 minus 5. Oh, you know what? I think it's B. Y'all in the chat, let me know. But my reasoning is because each midpoint is just adding 2. And I see that there's a plus 2 in my answer choice. As far as the 2 times I, yeah, 2 times 1 is 2. 2 times 2, or 2 times 0 is 0 plus 2 is 2. And then 2 times 1 plus 2, 2 times 2 plus 2. Yeah, it's got to be B. There's no way it's not. Actually, wait, hold up. Let me make sure. The absolute value of, ooh, you know what? It might be A, bro. Hold on, let me think real quick. So we need, okay, so for my first height, I should get 3. I'm just going to do whatever one gets me 3 for my first height. So it should come out to be the absolute value of 2 minus 5, which is -3, and then absolute value that. All right, so if I is 0, then we get -3 for my first height. If I is 1, then we get negative. Okay, yeah, it's A. It's A. I'm so glad I double checked. Ooh, I would have been mad. So that's the height, and then times the width is 2. Let's go. God dang. Okay, I'm so glad I got that one right. All right. Okay, so this one is pre-cal. This one is not even really calc. We are just summing up a whole bunch of things. So let's see here. 26. All right. Let's see. So if n was 0, then my first term would be 5m squared minus 0. Already, I think my answer is B. And then I'm going to go plus. Now, if n was 1, then that would be 5m squared minus 3. Okay. And then I would go plus. Now, this is if n was 2. This would be 5m squared minus 6. And then lastly, I would add 5m squared minus 9. 3 times 1, 3 times 2, 3 times 3. And then just simplify that. This is interesting because why is there only one answer choice with an m squared? I feel like that's too good to be true. Yeah, wait. Yeah, that's literally what I got. I don't even need to simplify. That matches B directly. So I'm going to go boom. It can't be that easy, bro. Is it? I guess they're thinking that some people are going to like confuse M and N. Okay, bet. Let's go. All right, y'all. We're getting closer. What are we on? 27 of 34, bro. We do not have that many problems left. What time is it? 11 o'clock? I'm in Central Time. Okay, so next question. Okay, bet. We'll keep it right there. All right, this one should be very easy. Integral from 0 to 1 of -12 e to the x dx. Oh, this one is super easy. I'm just going to rewrite it. The -12 I'm going to pull to the outside. Oh, I forgot the game came on tonight. I don't even know who won. I didn't check the score. I have to check in a second. All right, so that is the integral of e to the x dx, which is just itself. So that'll be -12 times e to the x evaluated from 0 to 1, which is just equal to -12 parentheses e to the 1 minus e to the 0, which is 1. So I could technically distribute that -12 to get -12e plus 12, because e to the 0 is just 1. So I'm getting answer choice C. Yes, Thunders versus Pacers. Who won? And was it a close, clutch, crazy game or no? I need to check highlights. Rudy, appreciate that follow. -12e plus 12. -12e plus 12, yeah. Oh, Thunder lost. Ooh. Dang, and they were in Indiana too. Okay, bet. Pacers up 2-1. That's crazy. Dang, man. It's a good series so far, but I guess we'll see what game 4 is looking like. Okay. Chat, we are on What number are we on? 28? Bro, we're getting close, and these questions are not hard, bro. They have low-key been blessing us with some easy questions. You had OKC in 6. Ooh, I don't know, bro. It really could go either way, I feel like, at this point. Y to the 10th dy. Is that really a problem? I'm shocked. Watch I like get a typo and miss this one. Imagine. Y to the 11th over 11. See, that's what I'm talking about. Over 11. They really put this on there? Y to the 11th over 11. Yes. If there's a dishwasher method on this test, I'm cooked. Nah. This unit is not disk and washer yet. That's unit 8. But those are hard questions, so I'm not gonna lie. So hopefully tomorrow, actually wait, what's tomorrow? Thursday? Oh, I don't even work out tomorrow. Tomorrow's a rest day. So I don't even have to go to the gym. I gotta go grocery shopping. That's what I gotta do. That's the only thing I gotta do tomorrow. I did laundry, I did dishes. Literally tomorrow I wake up, eat, grocery shop, stream. That's the plan. Okay. Number 29. Ooh, we're getting so close. Please, Khan Academy, don't give me no BS on the rest of this test. Please. Thank you. All right. Integral. I'm going to go ahead and rewrite this as x to the power of 2 over 5 dx. This one should be easy. Dishwasher shell. Trig sub is doable. Okay, bet. Yeah, trig sub is not that bad. I feel like it's just a matter of recognizing like different formats. But Chris, I don't know if you know, you can get notified whenever I go live, because in the next couple of days, I'm going to be doing disk and washer and all that stuff. So, but all right. Reverse power rule. This will be x to the power of 2 over 5 plus 1 is the same thing as 2 over 5 plus 5 over 5, which should be 7 over 5. I'm going to divide by 7 over 5, which is the same thing as multiplying by 5 over 7. That should be my final answer. Okay, bet. Yes, I appreciate the all of y'all joining the live, man. X to the power of parentheses 7 over 5. The plus C is already there for us. Double check. 5/7. Boom. X to the 2/5. Okay, yeah, we should be good. Let's go. Chat, bro. Chat. We're almost done. 30 of 34, bro. Okay. Oh, bro. They're blessing us. I just looked at the bounds. It's from 5 to 5. Let's go. Yeah, trig sub. Yeah, I'm pretty sure that's Calc 2. Okay. Bro. As I get closer and closer to the end of this, I keep on thinking like I'm going to make a stupid mistake. Bro. Vortex. I'm not tripping, am I? Integral from 5 to 5 got to be 0. Chris? You know definite integrals. Tell me I'm not tripping. Is there anything that I'm missing? Because if they trick me on some BS, I'm about to crash out. Okay, 0, bet. Okay. Whew. I'm starting to get nervous, bro. What are we on? 31? Man. All right, this one looks not bad at all, bro. They're blessing. They're literally blessing. Okay, number 31. Bro, we're about to get 100 first take. Let's go. All right. Integral of parentheses -1 over x plus 7e to the x dx. This is too easy. I'm going to separate them just for the sake of showing work. I can rewrite this as negative the integral of 1 over x dx plus 7 integral of e to the x dx. Okay, so the answer to that would be negative ln of absolute value of x plus 7e to the x plus c. My final answer is, oh, look at how they did answer choice D, bro. They're trying to, and A, they're trying to catch people slipping. Wait. Oh, I almost didn't see the difference between B and C. So we're thinking C. Yes, it is C. I'm getting C as well. Bet. Okay. Oh, this one should be easy. Match the function to its antiderivative where C is a constant. Okay, so let's see. The derivative of sine is cosine. So I'll go boom. And then yeah, I think it's this. Hold on, let me check. And instead of anti-deriving the left side, I'm just gonna derive the right side because in my brain it's easier. So 8. Ooh, wait, hold up. The derivative of sine is cosine. But if I were to do wait, hold up. If I were to do chain rule on top right, I would have to multiply by -2. Hold up. Derivative of sine. Hold on, am I tweaking? Is it this? 1 and -2, 4 and 8. You can just match it up because chain rule has 2. Wait, was I right the first time with this? Oh gosh, I'm confusing myself now. Hold up. Yeah, just look at the coefficients. Okay, yeah, I know the trig should be opposite. But if I do, okay, so this -10. The derivative of cosine is negative sine. Derive the left side. Oh, yeah, wait. Yeah, I'm tweaking. I was deriving the right side. Yes, whoever said derive the left side, thank you. I was tweaking. Antiderivative is the same thing as an integral, so I should derive the left side. Yes. I don't know why my brain told me to derive the right side. I was definitely tweaking. Okay. Cuz I was about to say nothing is really matching up. All right. This makes so much more sense. The derivative of, okay, so it should be like this then. 4 times cosine times -2. No, I had it right the first time. But the only thing I'm wondering, oh, wait, hold up. Oh, derivative of cosine is negative sine. So the -2 and the negative sign make a +8. Okay. Good Lord. I was like, is my brain not working anymore? Okay. Derivative of sine is cosine times -2 cosine. Okay, bet. We're good. Oh my goodness. That problem should not have been as hard as it was. Goodness gracious. All right. Partial fractions, we already know. Off rip. Partial fractions. Gotta be. This, we can tell this one looks different from, remember that other one we thought was partial fractions, but it was what? Polynomial division. One thing that I'm noticing is that there's 2 factors on bottom. So that's like something to look for. All right, let's try this. I was gonna say they should give us a partial. They hadn't yet. What number are we on? 30 what? 33? Ooh, we got 2 more, bro. I'm about to cry. Okay, 33. Let's not mess this up. So what I'm gonna do is I'm gonna show my work for real on this one because we cannot mess this up. So my original expression is 14x minus 1 over 4x plus 1 times x minus 2. And I'm going to set that equal to, here's partial fractions. The 2 numerators I don't know. So I'm going to let them be a and b. The two denominators are going to be my two factors on bottom. 4x plus 1 and then x minus 2. All right, so literally algebra. We just got to think what happens when I add two fractions. I need common denominators. So what I'm going to do is just create common denominators. So what I'm going to try to do is I know for this first fraction, I need to multiply top and bottom by x minus 2. Because those two x minus 2's over top of each other make a 1. So multiplying by 1 doesn't do anything. And then for the second fraction, I need to multiply top and bottom by 4x plus 1. Now I have common denominators, which means I can go ahead and write this expression as one big fraction. I haven't done partial fractions in like a month, maybe a little under a month. So hopefully I can remember how to do this. Okay, so since I have common denominators, I can write my one big denominator, x minus 2. And then on top, I got a times x minus 2. Actually, I'm going to distribute now. I'm going to just distribute now. So if I distribute my a, then I'll get an ax minus 2a plus I get a 4bx plus b. Okay, just set the numerators equal to each other. Ooh, yes. Wait, I think is that how I did it when I learned how to do it? Because you can definitely set those equal to each other. Oh, you know what? Because if I set those, I know it has to be a system of equations. If the kids can't add fractions, they better learn fast. Not for real. Cover method, bro. You know all these methods that I don't know. You need to put me on. Cover method. Well, I guess it doesn't help that I never taught or took BC, but I never learned this cover method that you speak of. The way I learned how to do it is we need a system of equations, one of which, like you said, we can set the two numerators equal to each other. And then I think what we can also do is set this equal to this. Maybe. I don't know. I'm going to try it and see what happens. So let's say a parentheses x minus 2 equals b parentheses 4x plus 1. That is an equation. Wait. Oh, yeah. We can set the numerators equal to each other because the denominator. Yeah, because the denominators are equal to each other. That makes sense. But because I have two variables in one equation, is that not what you're talking about? Let me know if I did something wrong. 4x plus 1. Wait. Hold up. Start skipping the steps. I'm scrolling up in the chat. Cover method. I never learned that method before. But I know those do have to be equal to each other. And then this ax minus 2a plus 4b plus 4bx plus b, if I set that equal to because I know I gotta either solve for a or isolate a or b first, and then wait a second. Yeah. System of equation. I know this is one equation. I think is my other equation this. Are those? I don't know if that's valid or not. This doesn't seem right. It's been too long since I've done partial fractions. Don't FOIL, find zeros. Okay. So when x is 2 and when x is negative 1/4. Okay, yeah, let me know. Because I feel like the way I'm doing it is not the most efficient way to do it. Yeah, I know this is not the proper way to do this. Because substituting that in for a is doing way too much. Okay, set the numerators equal to each other. Okay, I'm assuming you're talking about these two numerators. Then solve for a and b. Okay. So let me move this down real quick, even though I probably won't need it. So that's me solving for a. If I were to solve for b, I would get what? A parentheses x minus 2 over 4x plus 1. And then figure out, don't solve them like that. Wait, let me know what you mean. I got to get my dog up here. She's whining. Come here. Because I know you can isolate them, but solving for a and b. Okay, Vortex, you're going to walk me through this one. All right, assume you want to solve for b first. Okay, so a term needs to disappear. Okay. Yes. Set the factor with a equal to 0. So set x minus 2 equal to 0. So x equals 2. Is that what you're saying? Hold up, my cords is getting tangled. Now plug in 2 and then solve for b. Okay, so you can do it like that. So when we're trying to solve for b, we can let x equal 2. And then are you also saying that when we solve for the other variable, we can let x be negative 1/4? Okay, let's try it like that. Okay, bet. I like that idea. So here, let me erase this very bottom line real quick. I don't feel like I need that. So I'm going to go, so if I was trying to solve for b, like you said, that way you don't need a FOIL. Okay, bet. So that would be if x was, wait a second. If x was 2, wouldn't I get 0 on top though? Or am I doing this wrong? Oh, wait. Are you talking about solving for a? No, because in either case, I would get a 0 if I plug in an x for 2. They're adding. If you set the numerators equal to each other. Oh, okay. So I think, so are you saying like, if I let x equals 2, wait, that doesn't make sense. Because then I would just be setting one side equal to 0. I'm confused. Wait, so okay, so you're talking about setting the denominators equal. Wait, I'm so lost. Yeah. So the numerators are equal. So okay, wait. We're gonna go through this step by step, Vortex, to make sure I understand this. So these two things are equal, the two numerators. Common denominators. If the denominators are the same, numerators have to be the same. Wait. Uh-oh. I'm confusing myself, and hopefully I'm not confusing you. They're together. Oh, that's what you mean when you're saying they're being added. Is that what you're talking about? Okay, yeah. Okay, so that makes sense since they're being added. And see how it does it. Gemini AI. Yeah, I could. It'd be a better visual. But wait. If I'm adding the two numerators up, I know, bro, that would be clutch. I wish you could too. I mean, yeah. Yeah, I just need to see one good example. Set it equal to 14x plus 1. Oh, that's what you're talking about. So you're saying set those two numerators to equal to each other. My bad. You were literally saying the right thing. I was just not understanding. Okay, so that's what you're talking about. Okay, yes. From there though, you're saying from here, if I let x equals 2, I see. So if x equals 2, only that a term would go away. Got you. Cover method. I don't know if I ever learned it like this before. I see what you're saying though. So now literally just replace x with 2. Okay, bet. That makes sense. I know it's hard to explain math through text, so I don't fault you at all. We said x was 2 plus 1. And then, yeah, that is true. So I'm assuming then to solve for a, I would just let x be negative 1/4. Okay, I see. Minus 1 equals a parentheses negative 1/4 minus, instead of 2, I'll put 8/4. And then technically that'll be plus 0. That's a clutch move. You're goated. I did not get 100 on this test. Y'all got 100 on this test. What is that? 28 minus 1. 27 equals b times, or what is that? 8 plus 1 is 9b. B equals 3. Bro, that is clutch. Cover method. I got to type that in on a new tab so I can look into that some more. In addition to that tabular method, bro. I'm learning just as much as y'all. Partial fraction cover up method. Bro, there's so many methods. Let's go. You're putting me on right now. Hopefully you know that. All right, so we got B. Now, this seems like whatever, I'll just do it. So that's what, negative 14/4, which can reduce to what, negative 7/2 minus 2/2 equals a times negative 9/4. You forgot the minus 1. Oh, yeah. Okay, yeah, no, we're good. So this is what? Negative 9/2 equals negative 9/4 times a. And then to get a by itself, I'm just going to go ahead and multiply by negative 4/9 on both sides. I think Khan Academy heard me talking about how easy the problems were, and then they threw this at me. Okay, so on the right side, everything cancels out except for the a. On the left side, the 9s cancel and the negatives cancel. So I just got a 4/2, which is 2. All of that just for that, bro. That's crazy. Okay, now we can finally write this how we want it to. Now this problem finally became easy. So this problem now is the integral of, we said it was a over 4x plus 1 dx. I'll go ahead and separate it, plus the integral of b. I'm going to write it like this. I'm going to put my b right here and then integrate 1 over x minus 2 dx. And I'll go ahead and fix the first integral too to make it look the same. This is equal to 2 times 1 over. Good Lord, that was a lot. All right, u sub for the first term, u would be 4x plus 1. Du would be 4. And I'll need to divide or multiply by 1/4. So it's a. That's crazy. So 2 divided by 1/4. Yeah, that's 2 over 4, which is 1/2 ln absolute value of 4x plus 1. So that would be 1/2 times 1 over 4x plus 1 times 4. Okay, plus 3 ln absolute value of x minus 2 plus c. That was by far the most unnecessarily sweaty problem that we got. 2 times 1, 2. Oh, 2 divided by. Wait, did I mess up? How did you pull a 1/2? The 1/2 came from, what did I do? The 2 is here, but if I were to do u sub, I guess I should have wrote it out. If I were to do u sub on that first integral, my u would have been 4x plus 1. And then my du would have been just a 4 dx. And then the way I do it is, you see how in the original problem there's no 4 like there is here? To cancel out that 4, I need to put a 1/4. And so 1/4 times 2 is where I got the 1/2 from. Yeah. So we're thinking A, right? Should be. Bro, I gotta have y'all let me know. I'm scared. I'm not gonna lie. Because I'm 2 questions away. A, let me know. Okay. Bro, we're 1 away. We are 1 away. Oh, thank God. I practiced these the other day. I already know how to do this one. Let's go. I low-key can probably do this without work. I'm not going to do it, but I'm going to make a prediction. Let me zoom out a little bit. This is the finale right here, y'all, and then I'm logging off. All right, so first things first, because of the square root on bottom, I know it's either A or B. Off rip. It's either A or B. I want to say it's, I don't know. It's either A or B. Complete the square, yeah. And then there's like, it's all about formatting. Cause look, we can write this. I'm gonna only pay attention to the radical part, which is this negative x squared minus 6x plus 40. I'm gonna complete the square. Yeah, I know for a fact it's either A or wait. Square roots. Yeah, it's either A or B. But yeah, I know for a fact this one is a complete the square type of problem. But when that leading coefficient is negative, I'm trying to remember what they did. I guess we could factor out a negative sign, or they did it like this. What's up, Jaden? Yeah, I think they did it like this. Maybe, I'm not sure. And then we could also then write it like x squared plus 6x. Half of 6 is 3. 3 squared is 9. So I'm going to add 9. And then I'm going to also subtract 9 back. Jaden, what's good? Complete the square. Yes. So when I do that, my first three terms. Well, actually, I'm gonna do it like how they did it because I know the last two terms make a negative 49, which is a negative 7 squared plus x plus 3 times x plus 3. Okay. Factor out a negative from the first two terms to get. Ooh, that's right. That's what it was. Because I knew that negative 7 squared looked weird. So we're only going to factor a negative sign out of the first two terms. Making it a plus 49, not a minus 49. Yes. So it's like, it's that, and then it's a plus 49. What clutch timing of you to join us back when we're literally on the last question of the whole test. That is crazy timing. Okay, so that's what I'm looking like. And then if it's formatted like that, I know the answer is going to be an arcsine of the x plus h over the k. Am I doing Calc BC? Yes. Oh, you saw that it was the last problem and you wanted to see. Nice. Okay, yes. So format wise, this is B. Just to double check, I want to say I put this on the flashcards document. Let me see. Yeah, the second to last one right here. That's exactly what we're dealing with, I think. Yeah. Oh yeah, because we factored out the negative sign, so that negative sign should still be there. I factored it out, but I didn't write it. So that plus should actually be a minus. And then we can get our 100, and then we can celebrate. 1 over A, yes. Exactly what you said. You're a rising senior? Nice. Okay, so we are going with answer choice B. I think that's what everybody in the chat is saying. I agree. Let's go. 34 for 34. Thank you, chat. We're done. Let's go. All purple crowns. Let's go. Yes. Thank you for everybody who helped. God most definitely did on that one. Man, that was not just me. Vortex, that was you. Dr. Super Delicious, that was you. That was a team effort. Let's go. W's in the chat. Let's freaking go. I was going to be so mad if I had to restart that. Let's go. Whew. Thank you for the follow. That is a fitting moment to end the stream right there. Let's go. 34 for 34. I'm lit. Tomorrow, I'm going to try to get back on. We're going to do Unit 7's unit test. How many questions is that? Let me see real quick. Unit 7's test is, it's only 13 questions. Look. If I was super ambitious, I would knock this out tonight, but I'm going to, we're going to wait. We're going to save this one for tomorrow. It's only 13 questions, so not that bad. Differential equations. Diffie Qs. It's not that bad. What time? Good question. Honestly, the only thing I have to do tomorrow is go grocery shopping. So I'll probably do that in the morning. Let's just say 2 o'clock my time. Differential equations. Yes, they're fun. This should be light. I'm going to aim for 2 o'clock my time. That's when I'll go back and I will catch all of y'all then. My name is Mr. Allman. I just finished up year 3 of teaching AB. I never taught AB before, so this is why I'm trying to just learn it and get better. But yeah, I'm Central Time. I'm in Texas. Oh, you said I need to learn how to read. You said, what is your time? I read, what is your name? I'm so sorry. Tessa, nice to meet you. Okay, nice. All right, yes, 2 o'clock. That's the goal. Thank you everybody again who shared, liked, participated, donated. I think it's possible to learn this all over the summer if you do it for a few hours a day. Yeah. So, but all right, W stream. Tomorrow I'll be here. And then we'll do Unit 7, and then we'll do Unit 8, and then 9 and 10. Let's go. All right, I'm going to sign off. I appreciate everybody. I'll see y'all tomorrow. Let's go.